Welcome to today's first lesson on exponents. We're going to start with the product of powers property. And the first question is, what does a to the fourth mean in multiplication? So that really means a times a times a times a, which we shorten using exponents and write it a to the fourth. So in our first example, if we had a to the fourth power times a to the seventh power, what that really means is a times a times a times a as our first term. And our second term is a times a times a, and we write this out 7 times. 1, 2, 3, 4, 5, 6, 7. And when we put it all back together, we count them up, and we actually have 11 a's. So this is a to the 11th power. Well, that's really challenging to do if you had to write it out all the time. So I'm wondering if there's a shortcut that we can find. And we should notice that, wow, if we add 4 plus 7, we would get 11. So in your next example, you have b to the third times b to the fifth. Technically, that means b times b times b, and then b times b times b times b times b. And again, that's a lot to write out. It's simplified, becomes b to the eighth. So it would be a lot easier to just realize we can add those exponents. In our third example, we have a to the third, b to the third, c, times a b squared. Well, just for today's sake, I'm going to write this out. This is a, b, c, and then a, b. And I'm going to put all of my variables together. So I actually have a to the first, a to the first, a to the first, and a to the first, which is a to the fourth power. In my b's, I have b to the first, 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 which is b to the fifth power, and then the little c all by itself. It would have been much easier to just said, well, I had a to the third and a to the first and gotten a to the fourth power, b to the third and b to the second, added those exponents together, and then the c just kind of comes along for the ride. So the shortcut that we should be seeing is known as the product of powers property. And it basically says if you have the same bases, all you have to do is add the exponents. So a to the m times a to the n, we would just be adding the m and the n together. You have a practice down below. Take a moment, stop the video, and see if you can try those practice problems. Hope you gave yourself a chance to try those practice problems. Here are the answers. My suggestion is anytime you have a variable that doesn't have an exponent, that you stick the little 1 there so that you can remember to add. 5 plus 1 would give you 6. b to the first over here, and b to the first. That's how I got b to the first, and b to the first gave me b to the second. So if you need to, put the video on pause. Check that you've gotten the correct answers. The next part we're going to talk about is the power of a product property. And the question it says is, what does a to the third in parentheses squared mean? What that really means is we are taking a to the third times itself. And again, if we would write that out, that would be a, that's our first a to the third, times a, which is our second a to the third. Count them all back up and you get a to the sixth power. That's kind of a pain in the neck to do, so I'm wondering if we can notice anything about that. If I take a to the third, which is inside my parentheses, that's a power, and raise it to another power, what I'm noticing is 3 times 2 gives me 6. This is the power of a power property. Rather than writing it out, I can just multiply the powers. So if you look at your next one, it says a, b to the third, all raised to the fourth power. And again, my suggestion is always going to be, if you don't have an exponent, you put your exponent of 1. So now all I'm going to do is do a to the first raised to the fourth and b to the third raised to the fourth, I'm just multiplying powers. That gives me a to the fourth, b to the 12th. This is known as the power of a power property, which says to find a power of a power, all you have to do is multiply. So in our example down here, they have 3 to the 4th raised to the 2nd. All I have to do is multiply those exponents, and that would simplify to 3 to the 8th. So again, I'm going to ask you to take a moment and look at the two examples below and see if you could pause it and give them a try. We'll be back in a minute. Okay, so there were actually 6 problems here, and I hope that what you were able to do is realize that every power on the inside was multiplied by the power on the outside. The interesting ones are 5 and 6, because here we have fractions, and what we're doing with our fractions is everything inside the fraction is actually affected by that exponent. So if I was to write this a little bigger, I have 3 to the first raised to the second, and 3 to this first raised to the second. So you'll notice that both the numerator and the denominator get squared, and since they were plain numbers, I was able to evaluate them and come up with 9/4. In the number 6, x over 5 all squared, what I did was I had the numerator and the denominator both affected by the squared. So I did 5 squared and got 25. And then I had the same repeated term here. So at the end, I said, well, wait a minute. I have x squared times x squared. That goes back to what I learned on my previous page. That's x to the 4th power. And 25 times 25 is 625. So hope these notes are helpful. I'd like you to continue working on the next pages that were assigned for homework. Thank you.